Welcome to video 10.5b, calculating angle measures. So now we'll apply all the previous information we learned in the last video. All right, so we're given this figure. I've already marked up the given. So the measure of arc AB is 120, the measure of arc DC is 80, the measure of angle BAC is 50, and segment FG is tangent at point C. So what I suggest you do is when you're labeling your arcs, use arrows so you know 120 applies just to that and there's no confusion. Okay, so since all of the problems really depend on the measure of the intercepted arcs, I'm going to try to do that first and then go through all the answers. Okay, so let's see if we could somehow find this intercepted arc. Oh, I happen to know that I've got a 50-degree angle there that the vertex lies on the circle. So 50 degrees is half that intercepted arc. So if that's 50, that must be 100 degrees. And that's from right there to right there. Oh, I know in a whole circle, I've got 360 degrees. Well, I've got 80 and 120, that's 200. Another 100, that's 300. I've got no choice but for that to be 60 degrees. Okay, I've got all the arcs specified. Now let's attack the problems. These are all angles, 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 angles. All I care about is the vertex on, inside, outside, or at the center. And for angles, that middle letter is the vertex. So let's stress that middle letter. In all of these cases, middle letter D and C, that's going to be on the circle. So right away, it's just going to be half the intercepted arc. Some students get confused for what angle is which, so I suggest you grab two pencils. I'll use two rulers since this diagram is larger, and isolate the angle. So angle BDC. Okay, so D is the vertex. BDC would be this angle right here. The vertex lies on the circle. The intercepted arc is 100. So let's show our work. 1/2 of 100 equals 50 degrees. Okay, so please show your work so you can get some partial credit in case you make a computational mistake. Okay, ACD. Again, C is the vertex. The rays go through A here and D here. So again, the vertex lies on the circle. So it's going to be 1/2 the intercepted arc. I already calculated that intercepted arc to be 60. So as far as my work, it's going to be 1/2 of 60 equals 30 degrees. Again, angle PCF, C is on the circle. So let's isolate PCF. PCF will be this angle. I can clearly see the intercepted arc is 80, so it'll be 1/2 of 80 equals 40 degrees. Again, the vertex is on the circle. It'll be half the intercepted arc. ACG, so ACG looks like that. The intercepted arc is 120 and 100, that's 220. So again, showing my work, 1/2 of 220, that's 110 degrees. Now for these two angles, the vertex is not on the circle. So vertex is at point E. Point E is inside, and for inside I'm thinking half sum. Okay? So AEB, let's isolate that. So AEB is that. So I've got this intercepted arc of 120 here, and then I want to go to the flip side, and that intercepted arc is 80. Okay, so it's half the sum. So 1/2 of that 120 plus the flip side, 80. So that's going to be 1/2 of 200, so that'll be 100 degrees. Again, show your work. Finally, angle P, that vertex is outside the circle, So that's going to be half difference. So you just have to memorize those general statements that we went over before. Half the difference of the intercepted arcs. So let's grab our pencils again, or rulers in this case. And the intercepted arcs would be this one of 100 and this one here of 60. And I'm going to subtract. So 1/2 of 100 minus 60. It's always the bigger minus the smaller. We won't get negative angles here. So that's going to be 1/2 of 40, or 20 degrees. Whew. So there you have it, an application problem for how to calculate angle measures based on intercepted arcs.